Hey guys, I'm here back with another math video. Today we're going to be doing more paper folding. This time it's going to be from AMC 10A of 2014, number 23. And I actually took this test when I was younger. And back in those old days, we didn't have cyclic squares. So I actually had to end up skipping this question. But anyway, so just look at the problem, see if you can do it, pause the video if you need to, and I'll go with the solution. So assuming you've read the problem, let's try to solve it. So I've drew B over here, or what I think is B right now, based in my mind's image. So that's B right there. This is A right here, and we define the ratio between these areas. So first of all, let's set some variables. So a length whose square root 3 times the width has area A. So might as well set this to, whoops, bit of lag. Might as well set this to X. And since the length is 3 times the width, the square root 3 times the width. Oh my gosh, there's so much lag. Just ignore that. This is square root 3 times x. And since the length is divided into 3 equal sections, this would be square root 3 over 3 times x, and this would also be square root 3 over 3 times x, as well as this. Now let's draw a line down from here. This is x, since x is the width. The cool thing about this triangle is that it's 30, 60, 90. And how do we know this? First of all, we know this is a right angle because we just drew a line straight down, of course, and perpendicular and stuff. Based on common sense, it's a right angle. And x equals square root 3 times square root 3 over 3x. Now, the property of a 30, 60, 90 triangle is that this 60 degrees is 90, and this is A. This leg will be square root 3 times A, and this is going to be 2A if this is 30, 60, 90. And since this leg is x, and x is square root 3 times this leg, which is square root 3 over 3x, that means that this triangle is 30, 60, 90 because the ratio between the legs determines the angles of the triangle. So we know this is 30, 60, 90, which means that this leg right here is just 2 times square root 3x. 2 times square root 3 over 3x, since this smaller leg right here is square root 3 over 3x. So this leg is this. Now is where it gets interesting. First of all, let's try to draw this triangle right here, based on in this diagram A. So let me just try to draw approximately a symmetrical triangle right here. And what's interesting is that if you draw the triangle like this, you notice that the corner is touched. And the reasoning in this is that this is 60 degrees, this is 2 root 3 over 3x, and this, coincidentally, this leg right here is also 2 square root 3 over 3x. Sorry, getting a bit messy. And the reason for this is because both of these smaller legs are equal, and both of these smaller legs are root 3 over 3x. So 2/3 right from here to here is also 2 times square root 3 over 3x. Which means that if you fold the paper over along this dotted line, we know that this leg is 2 square root 3 over 3x. And we know also that this is 2 times square root 3 over 3x. And furthermore, notice that these two legs are split by a 60-degree angle. So we know that this is 60 degrees since the triangle stays congruent. And if this is 60 degrees, we know that this triangle is equilateral. And we also know that the corners touch. Because if this is equilateral, then this length, since this is also made up of 2 subsectors, is also square root 3 over 3x. So these corners should actually touch. These touch. Which is interesting. And what that means is that the area of this area right here actually should look something like this. And of course that's made up of this equilateral triangle. Let's find the area of that equilateral triangle first. So what is the area of this equilateral triangle right here? Label that E, and that would just be, well, just in case you guys don't know the formula, let's derive it right now. 60 degrees. Let's say this is A, this is 1/2 A, this length right here. Since this is 30, 60, 90, this is square root of 3 over 2a, and this would just be square root of 3 over 2 times a over 2 is the area. Oops, I meant a square root of 3 over 2a times a over 2. Since area is just base times height over 2, and the height is square root of 3 over 3a, and the base is a divided by 2. So this just equates to square root of 3a squared over 4. In this case, a is 2 times square root of 3 over 3x. Thus the area of this equilateral triangle is square root of 3 times 2 square root of 3 over 3x squared over 4, which is just square root of 3 times numerator squared is 4 times 3, which is 12 over 9 x squared over 4, which is 3 root 3 over 9x squared, which is root 3 over 3x squared. So that's the area of our equilateral triangle. What about the two right triangles that are on either side of it? They look sort of like this, square root 3 over 3x times x. Area of one of these is square root 3 over 3x times x over 2, which is square root 3 over 6x squared. Since there are two of them, you have to multiply this by 2, 6x squared. Since there are two right triangles on either side of the equilateral triangle, right here, this one and this one, you have to multiply by 2. So that would just be square root 3 over 3x squared plus square root 3 over 3x squared, which would just be square root 2, whoops, yeah, 2 square root 3 over 3 x squared. So that's B. What about A? Well, that's just x times square root of 3x. Width times height. Or width times length. Which is just square root of 3 x squared. So, ratio of B to A, which is just 2 square root of 3 over 3x squared divided by square root of 3x squared is equals to 2/3 x squared divided by x squared, which is 2/3. So if it's 2/3, that would be C. Alright, thanks. Angle A, and angle A, and angle B. And let's label this section right here Y. So what we know is that x plus y equals 8.5, because they just make up this side. And cosine of angle B is just y over x, because that's of course the definition of cosine. See, there's B and here's a right angle, so it's y over x. And thus, if we multiply both sides by x, y equals x cosine B. Okay, pretty good. Let's